Hello, my name is Erling Roberts. Welcome back. This time we're going to talk about picking the various components associated with the solar system that you want to create. Obviously there's solar panels, so you need to select your solar panels. The solar panels then provide power through the wires, and so you have to pick the right wires, and then those go to your inverters. Your inverters then take the DC current from the solar panels and convert them into AC current that you can use either in your house or in the grid or whatever. So we'll talk a little bit about those. And then the mounting systems is a pretty big deal, but we're going to cover those in later videos, so we won't get too much into those. Okay, so this isn't going to be a kind of an all in-depth review. It's just going to be a quick overview of some of the key elements that you need to know to look for when you're trying to spec out your components. And then some of it's really based on what I've learned in building my own systems. And I've done 2 phases, and so the 2 phases have really kind of opened my eyes as to what some of the differences were. So first off, you have solar panels, and I've got both sizes. There's 2 kind of common sizes that are used for homes and businesses, and so the one of them are 1.6 meters long. They're both a meter wide, and then one of them is 1.6 meters long and the other one's 2 meters long. The 1.6 meters is 40 pounds, and so it's relatively easy to pick up and hoist it to the roof, where the 2 meter panels that you see here, those are 50 pounds apiece, and they're a little bit ungainly, but they have some advantages as well. So the cost per watt. So the main thing in solar panels is cost per watt. So that makes sense. So you just take a look at the price and you take a look at the watts. That's the big deal. And the bigger panels tend to be a little bit cheaper, but not very much. Behind the simple cost per watt, behind that there are some performance differences. And so 2 of the key things that you want to look for is how long do they last, or basically how long do they guarantee that they'll stay above 80% of their capability. And so they're somewhere between 20 years and 25 years, so there are some differences there, and that's important because when they get to be that old you want to make as much power as possible. So that's the one thing. The other thing that's a little bit tricky for the beginner, when the sun is beating down, as we talked about last time, 1,000 watts per square meter, then you're getting the full rating of the solar panel. So whatever that number is that they sold you, that's what you're going to get. When the sun is off angle, and we talked about that in the second video, when it's off angle and you use the cosine to figure out how much direct energy is hitting the panel, you're not going to get 1,000 watts of irradiance. If it's at a 45-degree angle, as we said in the second video, then it's going to hit at 707 watts of irradiance per square meter. So that's 70%. Now, what we talked about before is, well, that's how much power you get, and that's not exactly true. Solar panels are less effective with less power than they are with full power. So as you have less and less power, you lose more. So at 70% irradiance, you might get 60% of the power. And so that number changes depending on the panels that you buy. So the first panels that I bought were whatever, I had no idea. But when I bought these panels, I kind of started to learn about this. I looked at it, and now that I've had them installed, and when they're pointing the same angle, when the sun kind of moves down a little bit, these panels perform a lot better than the old ones. So, that's an important trait. Okay. Next is the inverters. Inverters is probably the biggest decision that you'll need to make. I'll say there's 4 styles. The first style is you're charging batteries with it. Fairly simple, off-grid is what they're going to call that. I don't know anything about those. Okay, then for AC, and if you're going to try to run your house, you're probably going to need AC. If you're going to, I should say, if you're going to tie in with the grid, you're going to need AC inverters. There's 3 types. Your basic AC inverter, Sunny Boy makes them, and those, the solar panels make their voltage, they send that voltage to the inverter then converts that into AC. just like what it says in the box. Pretty simple routine. The second kind is where you buy one inverter per solar panel. And so they're kind of $100, $150, and they make AC right at the solar panel. And then instead of wiring DC back to the barn, you're running AC right from the panels. And so AC has an advantage that there's lower line losses, so your wiring might get a little bit simplified. So that's one way to go. Then the third kind is a hybrid. It's in between the two, and so it's Solar Edge. And Solar Edge makes they have the inverter, which is a lot like the Sunny Boy inverter, and then out at each solar panel there's an optimizer, and the optimizer is kind of like the in-phase inverter in that it's the brains, and it's out there at the panel. So what's going on? So what's going on is pretty clever. First off, your solar panels are making their voltage, and then the optimizer sees that voltage, but it says, well, I'm going to make 1 volt and send it down the wire back to the inverter. The inverter sees the 1 volt, counts them up, and says, okay, I got several 1 volts coming in, so I'm going to turn the system on now. So it sends a signal through the same wire back to the panel, the optimizers, and then the optimizers adjust their output voltage and current to meet the commands of the optimizer, and then deliver that power back to the inverter. So wow, that's a lot of money. And what's going on? The big deal there is that in a Sunny Boy setup, the simple setup, if you've got shade on one of your panels, then the remaining panels are limited in their ability to make power, because they're kind of being held up by the one weak panel. The optimizer sees the weak panel, adjusts the voltage requirements of what it can handle, and then the other panels can do their full amount of work with an adjusted kind of plan. So the optimizer allows the inverter to take command of all of your panels and command each one to meet its maximum capability. So if shade is hitting one panel, the optimizer kind of deals with it and gets the most amount of power that it can from all the panels combined. And so it's a fairly clever system that way. That's the first thing. The second thing, which is really clever as a novice installing this stuff, is that the solar panels won't produce voltage unless they're connected to the inverter and the inverter says go. And so when you're monkeying around with wires and things aren't all completely set up, the optimizers keep it safe so that there's only 1 volt on that DC wire. If all the panels are wired up on a Sunny Boy system and you put your fingers on there, you got about 400 volts DC, and that gets to be dangerous. So the optimizer system from Solar Edge is a little bit safer in my personal opinion, and it's clever, and so it maximizes the amount of electricity. Downside is it costs $75 for the optimizer, and then the inverter is about the same price as the Sunny Boy, so you're definitely not saving any money. So obviously the system has to make more power over its life than the cost of the optimizer. The optimizers and the inverters are guaranteed. I think the optimizers are 25 years and the inverters 12 years. So they come with a pretty hefty guarantee. So that's the inverters. That's your biggest decision. The last thing that I really want to share with you is to try and better understand kind of the wiring and what's the purpose and what's going on and how does the system work, so that you can specify the correct wires to run with the system. So wiring losses, I squared R, so current squared times resistance, tells you how much heat you're going to generate in your wires. And obviously heat generated in the wire is power that's not going back to the grid and making you money. So you want to minimize the amount of heat generated in the wiring in order to maximize the amount of power that you actually sell back to the company. All right, so you've got your solar panels, they're adding up in series. The optimizer in my case is telling them exactly what voltage and current to deliver. And so I've got 2 strings here. So there's 8 panels on each string, 2 poles on each string. and then that'll generate 400 volts and 15 amps of DC current. And so then, depending on the length of the wiring that goes to the barn, you get losses for that. Basically, these systems are designed so that you should be using 10 gauge wire, and no matter how long you run, you can survive, and the losses won't be too great with the 10 gauge wire. If you start wiring them up, all of these on one string, then you would overload the inverter. So the inverter can only take so much current, and it can only work with so much voltage. So as you're trying to figure out how to arrange your solar panels on strings to feed into the inverter, you're going to want to understand series parallel wiring, and you're going to want to follow the recommendations that come with your inverter. So that's an important consideration, which I learned pretty late in the game. Okay, thank you.